Okay, so this is section 11.3. We're going to go over some traversal algorithms. Hey, first of all, what is a traversal algorithm? A traversal algorithm is just a systematic way of visiting every node in an ordered rooted tree. So what that means is basically if you have data stored in some sort of tree structure, then you might want to go and read all of the data. And so visiting a node in that tree basically means like looking at that node and doing something with it, whether it's just taking the value of that node and printing it out, or taking it and adding it onto some running sum, or what? Like, I mean, whatever you happen to be doing with the data in the tree, right? So we're going to look at a few different algorithms for going through a tree, and specifically binary trees for these examples, and just visiting all of the nodes, okay, in some systematic way. So the first one is called pre-order. We're going to have pre-order, in order, and post-order. And the prefix there, pre, in, or post, is referring to when you visit the node itself, whether it's before, in the middle, or after. So for pre-order, here's what we're going to do. Whenever we visit a node, we're going to do the following. First, visit the node itself. So for us, that's just going to be printing the value of that node. And then 2, visit the left child, if there is one. And 3, visit the right child, if there is one. We'll start with the root, and then whenever a node is visited, repeat these 3 steps. So the shorthand that I'm going to use for this is NLR, which is do the node first, and then do the left child, and then do the right child. Okay, so we're going to go through an example of traversing an entire tree using the pre-order algorithm. So here is a tree, and so I've got every node labeled with its value, the letters A through I, and just so you know, this is a binary search tree. So that means that it satisfies the star rule from the previous lesson, that left child is always less in value than the node, which is less in value than the right child. And by value here, I mean alphabetical value, like alphabetical order. So let's begin. We'll start here at the root, and what we're going to do, whenever we visit a node, we are going to do these 3 steps in order: the node itself, the left child, and then the right child. So I'm going to write NLR next to that node. The first thing to do, this is basically like my to-do list. The first thing to do on my to-do list is to visit the node itself. So for us, that's going to mean just print out the value of that node. So I've got a little output over here. First thing I'm going to write is E. Okay, so that would be visiting the root. So now we have to go and visit the left child. All right, so I'm not going to cross that off just yet because we haven't finished doing that yet. So let's go and look at the left child. All right, now I'm looking at B. I'm going to write my to-do list. Here's my to-do list for B, NLR. So the first thing on my to-do list is to visit the node itself. So I'm going to visit B, and that means I'll print B over here. So I've done that. All right. Now I visit my left child. All right. Let's go down to the left child. That's A. All right, A, what's your to-do list? NLR. All right, first I'll visit myself. So that's, I'll print out A, the node we're on. Then I'll visit the left child if there is one. Do I have a left child? No. So I'm done with that. Okay. Now I'll visit the right child if there is one. Is there one? No. All right. So A has now completed its to-do list, all right? And notice I haven't completed the to-do lists from the previous, from like its ancestors up here. But that's because this was on the this is part of the to-do list of B, right? So now that I've completed the to-do list on A, now A is going to return to the node that called on it. So it returns back up here to B and says, I'm done. All right, B. All right, so B is now done with the second thing on its to-do list. It has visited the left node. Now it's time for B to visit its right right child. So now we're visiting D. Oops. I write out my to-do list in the correct order. We visit D. We visit its left child, which is C. C visits itself, and then it visits its left child, which doesn't have one, and its right child, it doesn't have one, so it's done. And then C returns to the node that called it and says, I'm done. So now D is done with visiting its left child. D visits its right child, doesn't have one, so now it's done, and it returns to B. And B says, okay, now I'm done visiting my right child. And then B is going to return back up to E. And E will say, I'm done visiting my left child. So now E says, it's time now to visit my right child, which is F. All right, F, here's your to-do list. NLR. So the first thing F is going to do is print itself. So there's F. And then it'll visit its left child, which doesn't have one. That's done. So it'll now visit its right child, which is H. All right, H. Visit yourself. Done that. Left child. All right, G. Oops. All right, G. Visit yourself first. Visit your left child. Nope. Right child. Nope. And then go back up to H. All right, H. Done with left. Now go to the right. Okay, I. NLR. Visit yourself. Left and right child. No, no. All right, all done. Back up to H. H is done visiting its right child, and it returns to F. F is done visiting its right child. It returns to E. And now E is done visiting its right child, and the algorithm ends. So that was a demonstration of how we kind of walk through the pre-order algorithm to traverse an entire tree. And right here is the output that I obtained. So here are all of the values that are stored in the tree printed out in the order in which they were visited using this algorithm. So in the next video, I'm going to go over the in-order algorithm and then the post-order algorithm, and we'll see how they are a little bit different.